Welcome back. In this video, we're going to start with physics input, and we're going to start scripting our player character in our RunJumper class project. So to start with, let's talk about physics. Um, the physics in Godot in a 2D game, there's forces and velocities and gravity and stuff like that. But for the most part, when we talk about physics, we're dealing with collision detection, detecting when two things either bump into each other, land on each other. So when we're running across the ground, when we've actually landed on the ground, or when two things overlap, so like picking up coins or other collectible items in the game. Those are all handled by the physics engine, and the physics engine is going to be able to do a much better job of detecting those collisions and then just letting us know that they happened. But we have control over defining what things can actually collide with or interact with other things, and we do that through physics layers. So we're going to go to our project settings, and we're going to find the physics layers. Ironically, it's not under the physics group. I don't know why. There's a whole separate group down here for layers, somewhere, layer names. And you've got a bunch of different categories. We're looking for 2D physics. And so we can define whatever layers we want. And it's going to change from game to game. You might have some games with more layers, some games with fewer layers. You may use different uh, physical layers like 1, 7, 10, or whatever. It's entirely up to you how do you define these things. But for this game, we're going to define 4 layers. The first one is going to be our player. Layer 2 is going to be the walls. Layer 3 will be our collectibles. And layer 4 will be our obstacles. So the collectibles are the things that we can pick up, and the obstacles are things that if we run into them or they run into us, then they kill us. So those are our 4 physics layers. Now let's take a look at how we use these. So we're going to go to our player scene, and our player is a character body 2D. And as we talked about last week, I think it was last week, a character body 2D, if we find that node type, oh, I didn't actually mean to add it. If we just find the node type character body 2D, inherits from physics body 2D, which is a collision object 2D. And so a character body 2D has all of the properties of all of its parent nodes. And the collision object 2D is going to give us the collision layers. So if we expand the collision section in the inspector for our player node, we can see there's all these layers and then there's all these masks. If you mouse over layer, it says the physics layers this collision object 2D is in. So this is going to define which physics layers this node belongs to. And for our player, we want it to belong to the player layer, which is layer 1. So that one's already kind of taken care of for us. It's automatically, for any new collision object, going to have layer 1 checked for both the layer and the mask. Now for the mask, this is going to define what other layers the collision object 2D scans. What that means is for each physics tick, what other layers is it going to check for collisions and overlaps and stuff like that. So for our player, we want it to scan the walls layer. So as we're moving our player around, we want to know if we hit a wall. And if we do, then we want to not pass through it. And the physics engine will take care of all that because of, well, I guess we haven't gotten to the scripting yet, but the script, the way that we handle movement in our script, it will automatically handle collisions and making sure that we don't pass through walls. So that's all we need to do for our player. We just need to tell it it is in the player layer, which is layer 1, and we want it to scan for collisions with the walls layer, which is layer 2. So now let's actually add our walls. So in our main scene, we're going to add the walls directly here. We could make a new scene for the walls, but this one is trivial enough. Let's just do it in the main scene. So we'll add a child node, and we want the base node for our walls to be a static body 2D. And if we look at the documentation for this, it says a 2D physics body that can't be moved by external forces. When moved manually, it doesn't affect other bodies in its path. Basically what that means is it's a thing that exists in the scene. You're not expected to use the physics engine to move it or to do collisions or anything like that. It's just a thing that is there. This is perfect for static geometry, for terrain, trees, walls, obstacles, stuff like that. And so we'll add a static body 2D, and I'm going to rename this walls. And this is technically going to be like the base node or the root node for all of our walls, both the top and the bottom. So uh, now we need to add our shapes. What do the walls look like? So we'll add a new child node. We'll add a collision shape 2D. And I'm going to call this top because this is going to be the top wall. Technically it's the ceiling, the other one's a floor, but we're just going to call them walls because I don't know of a single word that means both ceilings and floors. Walls is fine. So this is going to be the top wall, and we're going to position this collision shape at, let me see, where's transform? So I want this to be in the middle of the screen horizontally, so it's going to be at 512, and I want it to be 43 pixels down. So here's a little trick with the inspector. You can actually do math in the inspector. I said that I want this thing to be in the middle of the screen. Well, last time, or maybe it's first class. Yeah, last time. When we create our project, we set up the viewport to be 1024 by 768. So I know the width of the screen is always going to be 1024 pixels. And so if I want it to be in the exact middle, I could just say 1024 divided by 2, and it's going to do the math and just replace it with the value of that expression. So that can be really useful. If I want to move this thing by 63 pixels to the right, and I don't want to sit there and try to figure out what that is, I could just say plus 63, and now it's moved 63 pixels to the right. So that's going to be very, very handy if you want to make sure that you've got things like exactly in the middle or 1/4 of the way, or move something over by 16 pixels or whatever. You can just let the inspector do the math for you. So that's going to be the position of our top wall. Now we need to actually give it a shape. So I'm going to select the shape up here. We're going to give it a rectangle shape. And I'm going to select the rectangle shape so I can actually change the width and the height. And this thing is going to be 1190 by 106. So horizontally, this 1190 is kind of irrelevant. We could make it bigger or smaller or something. We just want to make sure it covers the entire width of the screen. The 106 is a little bit more specific, based on having actually made this game. I wrote down the dimensions of the top and the bottom walls. So this is going to be the top wall that our player could flip over and run along. Let's also define the bottom wall, and this is going to be the exact same as the top. It's just going to be in a slightly different position. It's going to be the same shape, same properties and everything. So rather than creating another node and giving it the same shape and position, all that, I'm going to duplicate this by right-clicking on it and saying duplicate. You could also select it and just hit Control D. And so now we have another collision shape that is an exact copy of top. And I'm going to rename this one bottom and change its position to 725 in the Y direction. So that's going to be our bottom wall, and this is our top wall. Now, okay, let's see what happens. If I play, actually, no, nothing's going to happen because we haven't given our player a script yet. So let's do that next. Let's go add some movement to our player. All right, so I'm going to define a new script, and I'm going to go up to my scripts folder, and I'll add the player script there. Even though I have recorded a separate video on the basics of scripting. Please go watch that first. That's going to cover variables, functions, statements, conditionals, all that sort of stuff. So I did all that in this project, but then for this video I deleted that script. So we're starting over with a new player script. Okay, so our player script extends character body 2D because that's what our player is. And I want a variable called gravity that I'm going to give it an initial value of 980. So this is going to determine how fast the player falls. And 980 is kind of a guess. That's an initial estimate. I may want to fall faster, I may want to fall slower. So to be able to edit this in the inspector, I'm going to make this an export var. Okay, sorry about that. Got interrupted by a kitchen timer. So my gravity, I'm making an initial guess of what I want the gravity to be, but I'm going to want to edit this later. So I want to be able to edit it in the inspector. So we're going to make this an export var. And now if I save that, we can see gravity shows up in the inspector, and we could increase this, decrease this, make changes without having to come back and edit the script. So for moving our player, we're going to use one of the built-in functions. In the previous video, I talked about a function called process that gets called right before every render frame. For movement or anything physics related, you want to use a different function called physics process. And this is like process, except instead of getting called every render frame, it's going to get called every physics frame. The code that I just removed, it gets put in there automatically by Godot when you auto-complete a built-in function. It's just defining the type of the argument that gets passed in, and it defines the return type for the function, which void just means nothing. These are completely optional. You don't have to include them. Sometimes I do, sometimes I don't. Because I haven't gone over them, I'm just going to remove them for this video. So in our physics process, this is where we're actually going to move the player. And that way it's done sort of in step with the physics processing. So to move our character, because we're extending character body 2D, character body 2D has a built-in property called velocity. So this isn't a variable that we've defined. It's a variable that's defined by the character body 2D class, but because it is a class variable, we can use it in our class. So each frame, we want the x velocity, that's the horizontal velocity, the velocity in the x direction. We want that to be 0. We're not going to be moving left and right. We just want to move up and down based on gravity. And so our y velocity, because velocity is a vector and gravity is a force, it's an acceleration. Acceleration is a change in velocity over time, and velocity is a change in position over time. So we're going to increase the value of our y velocity based on gravity. So we're going to use that special plus equals operator, which means add to the existing value of this variable. And the value that we're going to add is gravity, but not just gravity, because this is going to get called, every 1/30th of a second, and we don't want to increase our velocity by 980 every 1/30th of a second. And so this delta argument that gets passed in, this is how much time has passed since the last time this function was called. And so this should be like 0.033 or 1/30th of a second, or 0.016 60th of a second, whatever the physics tick rate is set to. And so we're going to scale gravity by delta, by time, because velocity is acceleration times time if you've taken physics. So we're going to increase the y component of our velocity by gravity times delta, which is time. So that's going to change our velocity each frame. Now to actually move, we're going to use a built-in function. This isn't a built-in Godot function. It's a function that comes from character body 2D. So we can use this function because we are a character body 2D. And that function is move and slide. So if we mouse over this and look at the documentation, it says moves the body based on velocity. If the body collides with another, it will slide along the other body by default only on the floor, rather than stop immediately. So we've set the velocity. We've said this is how fast this thing is moving, in which direction it's moving. Now we're going to let the character body 2D class actually handle the movement. And it's not just going to update the position, it's also going to do that collision detection. And if we run into something, it'll stop. It'll bounce off, or it'll move along it or something. So move and slide is going to do all the work for us. And then after that, we're going to check if We want to know if we've reached the ceiling or the floor, and then we want to stop falling. And so we can do that by saying if is on ceiling or is on floor. Just like move and slide, these are functions that come from the character body 2D class. So after moving, we can check to see have we hit the ceiling or have we hit the floor. And if we have, then we want to reset our y velocity to 0. Basically stop accelerating in that direction because we've hit something. So let's try this out. And we can see our player falls, but he just keeps on falling. He doesn't stop when he hits the floor. And the reason for that is because we have not assigned a physics layer to our walls yet. So let's go back to our main scene. We'll select our walls. We'll go to our collision tab. And we want this thing to be not in the player layer, but in the walls layer. And then we can remove the mask because the walls isn't going to be scanning for collisions. The walls don't move. It doesn't need to detect collisions. Our player will detect collisions with the walls, not the other way around. So all we need to do is put the walls into the walls collision layer. And now, if we run, the player falls and stops when he lands on the bottom wall. Excellent. So now let's see, how do we make him fall up? And the way we can do this is just by reversing gravity. So instead of 980, we can make it negative 980. And now we see he falls up instead of down. As pointed out in class, in a 2D scene in Godot, y increases down and decreases up. So it's backwards from like math and Cartesian planes and everything. And the reason for that is because on your screen, the top left corner is 0, 0, and your x pixels increase going to the right, and your y pixels increase going down. Think of it as how we read. We read from top left to bottom right, and that's how the pixels in a 2D scene are also organized. So to fall up, we need gravity to be negative, and to fall down, gravity should be positive. But we don't want to actually change the value of gravity each time. We just want to change which direction gravity is going. So we're going to add another variable, and we'll call this one gravity dir, which means gravity direction. And we'll give it an initial value of 1. Now this one does not need to be an export variable because we're not going to be editing it through the inspector. We're just going to be using it within our script. So let's add this to our velocity update line. So we'll say our velocity is gravity, let's just add it to the end. Gravity times time times gravity direction. So if gravity dir is 1, well, anything times 1 is just the same value. So it's going to be 980 times time. But if gravity dir is negative 1, well, now we've inverted it, and it's going to go up instead of down. So let's see what this looks like with gravity dir equals 1. We can see the player falls down. And if we change gravity dir to negative 1, now the player falls up. So now all we need to do is figure out how do we change the value of gravity dir whenever the player does something. So whenever we press a key or a mouse button or something, that will be our action to jump, which in this case means change the direction of gravity. So in your games, you will never, ever, ever add code to check for a specific key press or mouse press or button press or anything like that. It's not very flexible, and you don't want to be basing it off specific types of inputs or specific types of hardware. What your game cares about is, did the player jump? Did the player press a key or do an action that means jump? And so now let's get into how we define input for our games. So we'll go to our project settings, and up at the top there's a tab for input map, and this is where we can define all of the inputs for our game. Our game is going to be very, very simple. There is one input and it's jump. So let's click add new action. We're going to type jump, and I will click add. We could name this whatever we want. We could name it the jump action. We could name it super jump. We could name it do something. It doesn't matter. Godot doesn't care. It needs to be something relevant to us so that we know what this action is. So that is the jump action. Now we need to define what events will trigger this action. So for the jump action, over on the right, I'll click the little plus button that says add event. And here we can go through all of our keyboard keys, mouse buttons, joypad buttons, but it is listening for inputs right now. And so I just clicked and it registered left mouse button. I could press a key. I could press a different key. And so it's listening for key events or mouse events or whatever. So let me just press space. And that's what I want to use for my game. You may decide you want to be S or enter or up or whatever. It's up to you. I'm going to go with space and I will say OK. So if you press the space, it will trigger the jump action. But I want some other options. I also want to be able to jump when you press the mouse button. So I'm going to add that one. Maybe I want controller support. So let me come down here to joypad buttons and I'll choose joypad button 1, which is the Nintendo A button or the Xbox B button. So now I've defined 3 events. You can press the space key on your keyboard, you can press the left mouse button on your mouse, or you can press the button 1, which is different depending on the type of controller, but you can press a controller button. All of those things will mean jump. So that's how you define inputs. For other games, you might want to define actions for move up, move down, sneak, sprint, attack, dodge, stuff like that. Those are your input actions. So you're not concerned in your code about what keys or buttons trigger those actions. You just care about what actions can be triggered. So now that we've defined our jump action, let's go update our code to actually check for it or listen for it. So to do this, we're going to add another built-in function. And this one is underscore input. And input takes a single argument, which is the input event that triggered this function. So let's mouse over. Let's see the documentation. It says called when there is an input event. The input event propagates up through the node tree until a node consumes it. So any input event that's triggered, the input function will get called on all of the scripts in the scene until something actually responds and handles it. So we want to check for our jump action. So to do that, we'll say if event.isActionPressed, and then we give it the name of the action that we want to check for. And the IntelliSense is very helpful. It lists what actions are available to choose from, and we're going to select jump. So we'll say if the event is the jump action, if that was just pressed, then we want to jump. Now we could add the code to handle the jumping right here, and I think in class I actually did, but that's not a very clean, a very good way to do things. So instead, what I'm going to do is I'm actually going to call a function called jump. Now I'm getting an error because there is no function called jump. We haven't defined it yet. So let's go define a new function called jump. And the reason for doing this, it just kind of keeps the code clean. Rather than there being code to have the player jump, which ultimately is going to mean changing the direction of gravity, changing the animation, stuff like that. It's isolated to its own function. We know what this function does. It does one thing, it's jump, and now we can call that from anywhere in our code, even though we're only calling it from one place. It's just a cleaner way of doing things. So for now, all we're going to do when we jump is change the direction of gravity. Now I could check for if gravity equals 1, then change gravity to -1, else gravity equals 1. But that's not good. That's too much code. I'm going to keep saying this over and over and over. Programmers are lazy. We don't want to type more than we absolutely have to. And there's a much easier way to do this. That's by saying gravity times equals -1. So we're going to take whatever the current value of the gravity variable is and multiply it by -1. And 1 times -1 is -1. -1 times -1 is 1. So this has the effect of inverting the value of gravity regardless of what it is. If it's 1, it becomes -1. If it's -1, it becomes 1. Much cleaner, much simpler. All right, let's try this out. So I'm going to press the space key, and we can see gravity inverted. Now I'm falling up. Press it again. Now I'm falling down. Let me try the the mouse button. Actually, click in the game, not some other window. Now I'm falling up. Now I'm falling down. And I can change directions mid-flight. As I'm falling, I can press jump. Now it's going to change the direction that I'm falling. Beautiful. So we've got our input, we've got our jumping, we've got our falling. By changing our velocity, we can move and slide, or detecting if we hit the floors or the ceilings. And I didn't go over this in class. I guess I just had too many things going on in my head at once. But like I said at the beginning of this video, we made gravity an export var because we might want to change it. And as I look at this, that's really slow. I don't like how slow the player is falling. So let's change that. Let's bump this up 2x. So now it's 1960. That's better, but still not quite what I want. So let me try 980 times 3. That's better. So now I'm Now I'm falling a lot faster, whether it's up or down. Beautiful. Let me make sure I'm still recording. Something just went really weird on my computer, and I want to make sure I didn't stop recording. Okay, so we've got code to fall up and down. We've got code to handle our jump input event. And when we jump, we're just changing the direction of gravity. Last thing to do here is handle our animations. When we're on the ground, we want to play the run bottom animation. When we're on the ceiling, we want to play the run top animation. And when we're jumping, we want to play the appropriate flip animation, either flip top to bottom or flip bottom to top. So the way we're going to do that is in our physics process function. After we've checked if we are on ceiling or floor, this is going to, because we're doing or, if either of these is true, it will execute this code. Now we want to see which one is true. We want to know, are we on the floor or are we on the ceiling? So we can say if is on floor, we will do something. By the way, I should have included this in the scripting video. This is how you do a comment in code. You do the little hash symbol, and then anything that comes after that is a comment. Commented code does not get executed. It's just a note for yourself. I could come in here and like select these and press Control / and comment those out, and now that code's not going to get executed. I didn't remove it. I'm just not executing it. And then I can delete those pound signs and they come back. So I can say if is on floor, do something. Elif, so this is how you do, it's like an else and an if at the same time. So I can say elif is on ceiling. Did I spell that right? Do something else. Now, what we want to do, or do something else, is play the appropriate animation. And we're going to play that on our animated sprite 2D child. So I can just click and drag that into my script, and then I will call the play function on that node, and I will pass it the name of the animation to play. So this will be run bottom when we're on the floor, and it will be run top when we are on the ceiling. What does it not like about this? Did I misspell something? Yeah, it says if on ceiling not found. I probably just misspelled it. Okay, let's try that. So now, when we land on the ground, it starts playing the run bottom animation. Flip over, I guess we're not flipping, but jump, hit the ceiling, starts playing the run top animation. Excellent. So now we're playing the correct run animation based on when we're on the ground or the ceiling. So let's add the appropriate flip animation while jumping. So down in our jump function, after we invert gravity, let's check if gravity greater than 0. We could check for if gravity is equal to 1 or -1. We don't need to be that precise, so I'm just going to say if it's positive or negative. So I'll say if it is positive, that means I am falling down, going from the ceiling to the floor. So let's play the flip top to bottom animation. Else, play the flip bottom to top. And let's give that a shot. So now we're running on the bottom, and I jump and flip from bottom to top. Jump again, flip top to bottom. And if I jump while jumping, it's going to alternate between the two flip animations. Excellent. So that takes care of all of our animations, which is just running and flipping. There's one last thing I want to do, and I forgot to get to this in class, partly because we ran out of time and just because I was distracted. It's kind of hard to illustrate, but if I am jumping and I hit the ceiling while I flip over, once I touch the ceiling, this is on ceiling condition is true, and so it starts playing the run top animation. You can kind of see that. So I'm going to jump, and then while I'm falling up, I'm going to jump again just before I hit the ceiling. And you can see it plays the run top animation, even though I'm falling down. We don't want that to happen. So the way I can handle that is up here in my code that's checking for which run animation to play. I only want to play the run bottom animation if I'm on the floor and gravity is pulling me down. If I happen to touch the floor but gravity is pulling me up, I don't want to play the run bottom animation. So let's add another condition in here. If is on floor and gravity dir greater than equal, greater than 0, then play the run bottom animation. Else, if we're on the ceiling and the gravity dir is less than 0, play the run top animation. So now we should only play the run animations if we are grounded on the floor ceiling and the gravity direction matches which direction we should be running. So let's try that. So I'm going to jump and then flip over just before I hit the ceiling. You can see him bounce off the ceiling, but never plays the run top animation. So that's what we want. While we are jumping, we just want to play the flip animations, flip top to bottom, flip bottom to top. We don't want to play the run animation just because we happen to graze or bounce off the floor of the ceiling. So that should take care of our script. And I guess one last thing to do for this video is we don't have a visual component for our floor and ceiling yet. We're just kind of running on air, on nothing. And while that's fine, something's not working here. It's not playing the run top animation. Let's take a look. If on ceiling and gravity dir less than 0. That is a bug. I need to figure out why that's not getting hit. I will take a look at that and I'll report back in class because I don't want to sit here for however long while recording a video and try to debug that. If I remove this, does it go back to working? It does. It's curious. So I'll try to figure that out and I'll report back. So last thing we want to do, let's add a visual representation of our floor and ceiling temporarily, just to kind of help us while we're building the game. We'll eventually replace this with like actual background and floors and ceilings and stuff, but since we don't have that yet, this will just help us out a little bit. So I'm going to add a child to the walls. I'm going to choose a color rect. And we don't need to be quite as precise with this. Let's just kind of drag. I'll zoom in a little bit and try to get it mostly overlapping the collision rect. And I'll give this thing a different color. I'll make it sort of semi-transparent blue. And then I will duplicate that, move this one down somehow. There we go. Change the color to orange. That's fine. And I will drag this up to more or less align with the floor collision object. So now if we play, we have an actual visual representation of the floor and the ceiling. So that's going to make it a little bit easier. Probably should have done that before we got into the scripting, but now we have it to play around with. Okay, I will try to figure out why this is not working in the script for the run animation. If you can figure it out, I would be happy to hear what I'm doing wrong at the beginning of class next time. Otherwise, I will announce how to fix it. All right, y'all have a good week.